Okay, so I'm gonna start now. So I think mainly I'm gonna end up focusing on graphs, but we can do everything in trigonometry because I think that there's quite a lot, there's quite a bit on this single topic to cover. Let me just take my maths book. Yeah, I'm gonna start with the basics. Okay, does anyone need me to explain sine, cos, and tan? No. Okay, so by now, if you don't understand the concepts of sine, cos, and tan, then you should not even attempt writing the test tomorrow. So sine, cos, and tan. These three things are gonna be everything that we're gonna. These three things lead to everything. So starting with the basics. Let's say I have this triangle, and this is 90 degrees, and this is 48 degrees, 5.1 meters, and this is, let's say, 3.2 meters. Okay, no, let me not give this measurement. Do you know, can someone can unmute and tell me how to do this? Um, who's the, okay, I'm sure, can everyone do this? So simple stuff, because I have the hypotenuse and let's say I want these two lines. We're gonna, so first we have the hypotenuse, sorry. So let's say we want to solve for this side. Let's call it, let's just give it labels here, A, B, C. So let's say we want to solve for CB. Now CB, in terms of this, is adjacent. So we have the adjacent, we need to get the adjacent. So we're going to use cos because we have the hypotenuse already. So you need to equate it. So you're going to say cos of 48 is equal to, now it's adjacent, so CB over 5.1. Then you use your basic equation skills to get CB on its own, times by 5, comma 1 on both sides. So you get 5.1 cos of 48 is equal to CB. Then you just put this in your calculator, times cos of 48. And you get 3, comma 4, let's say 2 decimals, meters. That's CB. Okay. If I were to, let's say, I'm given this triangle. Let's say this length is 5, 4, and 3. And it asks for this angle here and this angle here. Are you guys able to calculate that? Okay, so it's simple. Okay, so first we need to set up the equation. Trigonometry is all about setting up your equation. If you cannot set up your equation correctly, your answer will definitely be wrong. So in this case, we want to say, let's say this is angle A, B, and C. Now we know for, let's just say they want to solve for A. Right. Now, there's many things we can do. Let's just say this length was not there. Right. So this is angle A. And we have the adjacent, which is 3, and we have the hypotenuse, which is 5, meaning we're using tan. So tan of A must equal to 3 over 5. Right. Then, in order to cancel out tan, and we take it to the other side. Yes. Yeah, we are allowed the cheat sheet.
MP, how do we know that we're using 10?
Oh, sorry, not 10. I'm tweaking, my bad. It's not 10, we're using cos of A.
Cos.
Right, because we have the adjacent and the hypotenuse. Right, so that's 3 over 5. Then A, we bring cos over, so it's cos to the minus 1. 3 over 5. And just put this in your calculator. So its second function, cos 3 over 5. Now, before you write maths, you must always make sure your calculator is cleared. So clear it out. Because, for example, like Sandiso, you may have your calculator in gradients mode, which will throw it off. So you should get 53, comma, let's say 13 degrees. That degrees symbol very important. If you don't put it there, then you're gonna lose a mark. Right. Now, this is the basics. It's gonna get more difficult from here on out. Right. So let's say you're using. Okay, wait. Let me just check if I'm going in the right order. Second functions. Okay, special angles. Special angles are quite simple because all it is a table you need to memorize. So it's opposites, adjacent, hypotenuse. 0, 30, 45, 60, and 90. The first row is 0 to 4. Then the second row is 4 to 0. And this is all 2. Now, the first, yes. Oh, let me just, okay, right. Now, the first 2 rows you always square roots. So I'm going to do that now. So you put square roots on every single one. And hypotenuse stays as 2. Right. Now, what this means is if I ask for cos of 30 without a calculator, you must be able to say cos is adjacent over hypotenuse. Therefore, for 30 degrees, it's root 3 over 2. Right. Now, that's quite simple, right? Now, the only thing you have to worry about is you allow the calculator. However, let's say we say, let me just make sure it works like that. Sine. 10 of 30, I'm pretty sure. Yeah. Okay, right. Tan of 30 is a tricky one because according to your special angles table, tan is opposite over adjacent. So it's root 1 over root 3, which is just 1 over root 3. Now, if you put tan 30 in your calculator does something interesting. Because what it does is, calculators don't like having a square root in the as a denominator. So what it's going to do is going to say times root 3 over root 3. So that's going to be root 3 over 3. So when you put tan 30 in your calculator, you get root 3 over 3, which is wrong. That's how the teachers will know you are using a calculator. So just be careful about that one. The other one is, I think there's another one. Mm, I think it's, oh yeah, the 10 of 45. No, 10 of 45 is one. Okay, well, that's the main one you have to look out for. But it's best if you just know this table because it's quite quick to memorize, right? Now, for example, I can say cos of 30 squared plus 10 of 60 squared. Cos of 30 is root 3 over 2 squared plus 10 of 60 cos of 30. 10 of 60, 10 is this here, so it's root 3 over root 1. Good. Then that's 3 over 4 plus 3 over 1. And then you just put, do you see from this step here, you use a calculator. So if you put this in, then you get 15 over 4. And if it asks for this, leave in two decimal places, then it's 3,75. Right. Now, this opposite can be done where, let's say you get root 0, let's say you get cos of x is equal to 0. 2 root cos of x is equal to 0. Right. What this means is you want to get cos of x on its own. So you're going to say cos x. Now divide both sides by root 2. That's 0 over root 2. From here we can see, okay, from our special angle table, 0 and root 2, and it has to be cos. So adjacent over hypotenuse. That means that it's 90 degrees. So therefore, x is 90 degrees in this case. Okay, right. Does everyone how understand special angles and how to use them? Okay. Now, next, I'm pretty sure is the cast diagram. Yep. No. Determining lengths, I went over that. Right. Do I need to go over how to find angles and lengths? So if I give you, for example, let's say I give you this one here, where it goes, oh no, wait, I did this with you guys. I did it here. Right. Okay, you understand this then, where you have to find an angle or maybe a length. Okay, right. Come with your videos on. Your camera's on. Okay, now what problems are you just have to look at it carefully. Now something I'm going to teach you is the angle of depression. I'm going to teach you two things that's in the textbook that I don't think so went over. Right. This is known as what is it known as? Just make sure I'm right. Yeah. The angle of elevation. I was correct. Angle of elevation. Now, this on the other hand, this is known as the angle of depression. Now, this line here is supposed to be dotted, but because I won't, can't draw it straight here, it will be just like that, right? Now, what this states is, because if they draw a dotted line, that means this and this is parallel, meaning you can get an alternate angle here. You get a Z or an N. Therefore, that means this is equal to this. So that's quite important when you're solving because sometimes they give you the angle of depression and you have to look for the angle of elevation. But angle of depression will equal the angle of elevation. Right. Now, um, does everyone understand this concept? Because I know Mr. Dula didn't teach this one specifically. Right. Um, then next, now the cast diagram. Now you guys don't know it as the cast diagram. You know it as using a diagram. The question will ask for using a diagram slash in terms of slash without a calc. Now, what this means is, let's use this example. Let's say 5 cos plus 3 is equal to 0. And they say that, okay, and there's no extra information in this example. No, wait, there is. Let's say, then they say that the cos of x. And then they say x is an element of 90 to 180. Let's say 180 and 270, 360, let's say rather. Right, now what this means is, draw a small diagram here, 0, 360, 90, 180, and 270. Now, because all students, no, students take candy, right? However you remember it. Now, this means everything is positive. Your only sine is positive, your only tan is positive, your only cos is positive. Right. Now we know that it's saying x lies between 180 and 360. So these two here, these two quadrants. Now, that's all they give us for now, but if we simplify this expression, we can get it. So cos of 5 cos x, we bring over the 3 minus 3. Then it becomes cos of x is equal to minus 3 over 5 because you divide both sides by 5. Now, what this means is that's minus 3 over 5. That means cos is negative. And in which quadrant is cos negative? This is 1, this is 2, this is 3, and this is 4. Right. Right. And so it's negative in quadrant 2 and 3. But because only quadrant 3 is applicable here, it's this is the one. So it's in quadrant 3. Right. Now, once you get that information, you can start drawing. That is not straight at all. Doesn't not have to be accurate. Right. So we know that it's going to be in quadrant 3. Now, x must always face the origin, meaning you draw the triangle like this. Now, 3 Cos is your adjacent over hypotenuse. Now, that means that when you draw the triangle, it's going to look something like this here. Right. Now, adjacent side to this is this one here. So it's minus 3 and 5. Now, next thing we need to do is Pythag for the missing side. So what we're going to do is 5 squared minus 3 squared. You don't carry over the sign here. Well, you do, but you do it like this here. And then that's going to give you 4. 4 is your missing side. Now the question is asking for tan squared x, sorry. Now we know tan is your opposite over hypotenuse. Therefore, this is your sorry, it's not opposite. My bad. That's opposite over adjacent. Now, this line is opposite and this one is adjacent. Therefore, it's going to be. Now, something I missed here, it's minus 4. Because as you can see, the triangle is in quadrant 3. That means it's below the y-axis. This is 0 and 0. This is your origin, which is 0 and 0. But because the triangle is in the bottom half of the grid, that means that this side it has to be negative. Because tan is positive in Q3. Yes.
Okay, so then since it is what is it called? Below the y-axis. Why wouldn't 5 be negative?
The hypotenuse is never negative.
Oh yeah, yes, yes, yes.
Because when you square it, the sign just becomes positive.
Oh yeah, 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 yeah. Oh, okay, understand. Then why is the -3 negative then if it's above the y-axis? Or is that
No,
just
because
hypotenuse?
that's your x. That's so you see, right? The 3 is going in the y on the x-axis, right? It's going this way. This side, this this side is 3 units long, right? But in which direction? To the left,
Left.
right?
Okay, that way.
Now we know anything to the left is on this side of the graph is negative.
Negative, yeah, yeah.
This side is positive.
Oh,
And because also cos of x is positive and negative, right? Hypotenuse cannot be negative, therefore 3 has to be negative. So when you plot a point on the graph, let me look for a different color. Let's say you're plotting this point on the graph here. The point is -3 and -4. If you were to plot that, this point here is -3 and 0. This is 0, 0. If you understand what I'm, you understand that?
yeah, I'm getting you. I'm getting you.
Yes, Gabby.
I need to use Pythagoras for this question.
Yes.
Yeah.
What's your question? Your mic cut.
Are we always gonna use Pythagoras in this question?
Yeah, so normally when they ask this question, they ask for sine, tan, or cos, right? Whatever the data they give you, let's say it's cos, they're going to ask for tan and sine, for example. So your next step should be to get all your sides. In this question, we don't really solve for the angle. We get all 3 sides. So yes, you should use Pythag. Right. Now, opposite over adjacent. Now, adjacent is, so that's -4 over -3, which is 4 over 3. That's your answer. Or squared. So this is squared, and that gives you 16 over 9. That's your answer. Right. Sometimes they don't give you the statement. Sometimes they may say, cause the quadrant it's in, for example, instead of saying this, for example, you could say that tan of x is greater than 0. Therefore, you know tan is positive, but once you solve for cos, you realize it's negative, and therefore it's that quadrant. Do you understand this diagram? How to solve? Is there any questions? Or can I move on? Okay. Yes. Yes.
How do we know? How do we know whether to choose which values are negative, or does it depend on where
What
we
do you
plot?
mean? So look, when you plot, right, in this case, because let's say instead of cos they gave us 10, and they were one was negative, the fraction was negative, right? Now, but let's say 10 was negative in the second quadrant, right? Because it's on your x values are going to be in the negative. So what do you mean now? So they will ask to say using a diagram slash in terms of slash without a calc. So they're going to give you this statement. 5 cos x plus 3 is equal to 0, and let's say x is an element of 180 and 360. Then, using a diagram, or in terms of, or without a calculator, solve for tan squared x. That's how they're going to ask the question. See, clear, did I answer your question?
Yeah, yes, you did.
Yeah, right. Next. Um, right, reciprocals. Quite easy when you understand them. Sine, cos, and tan. The fundamentals that we've learned so far. However, reciprocals means the inverse. So if I say 1 over 2, the reciprocal is 2 over 1. That means that there's three reciprocals. There's cosec, there's sec, and there's cot. Now, cosec is 1 over sine. Let's say x. Sec is 1 over cos of x. Cot is 1 over tan of x. Now, the way I remember this is if you check the third letter of each one, it's what it actually is, because the third letter of cosec is S, which is sine. The third letter of sec is C, which is cos. The third letter of cot is tan, T. Right. Now, there's another. So, what this means, sine, the inverse is sine is normally opposite over hypotenuse. Now it's hypotenuse over opposite. Cos, uh, this is hypotenuse over adjacent. Cot, adjacent over opposite. So quite simple. Now you use this one for special angles, and we mainly use this one. So if I ask you what is cot of 60 degrees, 10, which is 1 over 10. Cot of 60 degrees is 1 over 10 or 60. Now you go to your special angles table and you check that. Tan of 60 is 10 is opposite over adjacent. So root 3 over root 1. So tan of 60 is equal to root 3 over root 1. But now 1 over 10 is root 1 over root 3, because we just invert the fraction in this case. Makes sense? Okay, does everyone understand reciprocals? Now, for example, let's say I say cosec of 60 times sine of 60. Now, we know cosec, hypotenuse over opposite, and we know sine is opposite over hypotenuse, meaning when we do it, it will cancel out like this and you'll get 1. So when you times something by its reciprocal, you get 1. Right. Now, I think that's yes. Okay. Now there's one thing left. Now before I continue, that makes up quite a large section. Before I continue, does everyone understand everything so far? Okay. Let me just get ready for this. Okay, right. Graphs. Probably the most difficult part of this section, graphs. Right. Now, there's sine, cos, and tan. But what a graph is, we know your straight line graphs. Where okay, never mind, let me not. So it's quite simple. So there's only three functions, sine, cos, and tan. However, your formulas is y is equal to a times sine of whatever times k times no sine of x times k plus q, and this is repeated for cos of x and tan of x. Same thing. Right now, yes, Gabby.
Philip said there's no 10 graph for tomorrow. Only sign and cause.
Okay, well, I suppose are we gonna trust? Question is, are we trusting him? Because I would hope I can trust him, but yeah, yes. Oh no, never mind. Okay, but in that case, I'm on. Do you guys still want me to go over 10?
No.
Okay. Okay, in that case, that makes it much easier. Okay, right. Yes.
Big P, will we need to know like to calculate equations for sin and cos graphs?
What do you mean? Oh, yes, like that. You mean
Yeah,
like where it gives you a graph and then you have to make an equation for it?
yeah. This
Probably.
isn't. Oh, chai.
I'm gonna go over it now. Right. Sin, cos are the easier ones. So if we look here, 90, 180, 270, 360, minus 90, minus 180, minus 360, minus 270, and minus 360. Right. So this is a sine graph. Sine, no matter what, will start at 0, 0. Well, the base graph starts at 0, 0. That means that it goes up at 90, comes down at 180, and then goes back up. It goes back like this here. So let's say this is 1, and this is minus 1 here. So that means at 90, here, it's going to hit 90 and 1. Then here at 180, it's going to go 180 and 0. Then here 360 and 0. However, at 270, it's going to be 270 and 1, minus 1. Yeah, and then 0 and 0. Upload that right. Yep. Okay, quite simple. That's the base graph, right? Now, cos is similar, except not really, because at 180, 270, and 360. Right. Now, cos is quite similar, except it doesn't start at 0, 0. This is 1, this is minus 1. Your graph for cos, if it's not vertically shifted, or the base graph starts at 1, then what it does is it does this. Goes down, that's not a good representation, goes down to 90, hits the lowest, goes up at 270, and it goes up at 360. So these graphs, one period, one cycle of the graph will end where it started. If it starts on the 0 on the y-axis, after one cycle it ends at 0. Same thing here, because this is 0 and 1. This is 90 and 1. This is 180 and minus 1. That's 0, sorry. Then 270 and 0. 360 and 1. Now, how do you check? Now, first, you need to make sure there's no vertical shift. Now, what your vertical shift is Q. Now, how do I identify that? By checking your amplitude. Because, let's say, for example, we have a graph like this here. And let's say it starts here. This is 90, 180, 270, 360. Right. And let's say the graph starts here at 1 and minus 1. Now, let's say this was hypothetically, you don't know what this graph is. And it goes up, then it goes down. So here's 2, goes down. Let me redraw that rather. Goes up, then it comes down, goes lower, and it comes back up here, 2, 1. Now, you can see that this is a cos graph. I mean a sine graph. And the reason for it is that because here at 180, it must, well, obviously this is not accurate, but it hits 1. So if it's 0, 0, it starts at 1, but then the next thing it goes up. It's either sine or it's a minus cos. But at some point, even if the graph is inverted, at 180 degrees, a normal sine graph hits 0 and 0. It hits 0 on the y-axis. But a cos graph, even if inverted, will not. Now, thing is that um right. So you just have to look out for that, because let's say you're graphing, all you have to do sometimes is you have to look at the points, because the points can give you information. Let's take an example from the textbook. Okay, right. Let's look at this example from exercise 5.14. 90, 180, 270, 360, 2, 1, minus 1, and minus 2. Right. And the line goes from 2 down to 90. Oh no. Goes like this down to 180, then comes back up. It's up already at 270, so it's like this here. And then it stops, it bottoms out at 360. Okay. Right. Now, this is your starting point here, 2. That means that when it hits 2 again, it's completed. Something's not right here. Oh no, sorry, that's a different line I'm looking at. I'll mix them up. Okay, so look at it like this here. Right. So it starts at 2, it goes down to 1 here. It's 0, goes up to 1, and goes to 2 again here. Now, now, in this example, they give you y is equal to a cos x plus q. Right. Now, a is your amplitude, max minus minimum, over 2. So your max is 2, your minimum is 0, therefore your amplitude is 1. Now, what you do from here is you sub in a point. So let's use this point here, 0 and 180. 0 on the y-axis. So a is 1 times cos of 180 times by a plus q. Right. Now all you do, cos of 180 is minus 1. Right. Now, times z plus q equal to 0. Okay. This means that using equations, we can see that minus 1 plus q, bring that over, that's 1. So q is equal to 1. Now once you get q, rewrite the sum. So you get y is equal to 1 cos x plus 1. Now in this case, it's given to us. However, let's say it's not given to us, like C. Right. I'm looking for C, I'm looking at not the tan line. So it starts at minus 2. Right. Goes 90, 180, 270, 360. Right. Now, the line goes 180 and 4. Goes like this here. Must actually extend it out a bit here. Because it goes to 4. Does it dip below 4? No. Okay. Right. So that's already a bad sign that it's not dipping. It goes up to 4, but it doesn't dip. It doesn't dip all the way to minus 4. Right. So what this means is we can already identify that this graph is shifted. Because if you see here, what's your highest point? 4. What's your lowest point? Minus 2. It should be minus 4 if this graph didn't have a vertical shift. Meaning that This graph was shifted up. That means we can see that Q is already greater than 0, meaning that we can identify what Q is. So rewrite. Now, here's my question. How would one identify if this is cos or sine? Now, that's so once we've identified there's a vertical shift, we need to try and figure out by how much. Now 4 and 2. To get them equal, you would say 3 and minus 3. Because let's say if we bring this graph down by 1, the highest point will be 3, the lowest point minus 3. So we can see already, okay, 3 and minus 3. That means this graph was already shifted up by 1. So we know Q is 1. Keep that in mind. Now, if we shift down, look at the purple line here, by 1. This is the new graph. Right. Is now who can tell me the one property of a sine graph? By 180 it hits 0. By 90 it's over 0. 180 and 360 are 0. Now, here, by 90 it's 0. By 80 it's not 0. And because we've identified the vertical shift, that shift did not change the graph itself. And by 270 it's at 0, not by 360. So we know now that okay, it's not sine. It's not a sine graph. It is in fact a cos graph. Because a cos graph, as you can see here, by 90 and 270 it hits 0. So once you almost identified your vertical shift, then it's easy to pick a formula. So y is equal to a times k cos of x plus q. Now, let me explain something. K is the period. So let's say now the period is one full cycle. So from start, let's say it starts at -2. When it comes back down to -2 again, that's one full period. That's one full cycle. So most of the time k is equal to 1. In tomorrow's test, it's also most likely 1. Now a is your amplitude. So max minus min over 2. Now we don't use the new graph the purple graph we use the red one. So 4 minus 2 over 2. So then that's just plus 2, so that's 3. So a is 3. Now we sub a back into our formula. K we're going to assume is 1 in this case because it's not given to us. Cos of x plus q. Now we've already identified. Now, think about cos. If you can see here, according to the standard cos graph, it starts at 0, 1, but then it dips down. It goes down. Sine, on the other hand, goes up immediately, if you can see here. So it's 0, 0 goes up. Cos goes down. But what is this one doing? It's going up. But we already know it can't be a sine graph because at 180 it's nowhere near 0, even with the vertical shift. Therefore, a has to be negative because the graph is flipped. Because a cos graph does not look like this. A cos graph will look like this here. A sine goes up then down. However, inverted sine goes down then up. The only difference between inverted sine and a normal cos graph is where it hits 0. It will be on different points. So now, after we sub in values, let's look at a value here on the graph. So 90 and 0, let's use that because it's easy. Times cos 90 plus q. Now, cos of 90 is 0. So, okay. No, let's not use that point. Rather, let's use 180 and 4. 180 and 4. So cos of 180 is -1. So minus 3 times minus 1 plus q. Right. Now if you times this, you get 3q. Right. You bring over that q, you get q is equal to 1. Then when you've done that, you rewrite your formula. So y is equal to 3 cos x. Don't include q, doesn't matter, plus 1. Okay, does everyone understand graphs?
Yo, I can't lie. It's shy for graphs, bro. Not gonna hold you. That's the
Look,
worst, bro. But
I've
I'm
almost put it in the simplest terms possible. So I understand why graphs is difficult because I'm also learning it for the first time. Because even in further studies last year, we weren't taught graphs in trig.
but then I am getting it. I'm getting it. I will also do some graphs later today. So yeah.
Right. So the first point, if you're given a graph and asked to put a formula, identify if it's cos or sine, because there's no tan graphs tomorrow, and you can tan is a, let's say, a funny looking graph. You'll be able to identify it at first, but we're not getting tan, so it's fine. The problem is you need to know how to identify a cos and a tan. I mean a cos and a sine graph. Sine, well, it's 0 at the positive, so 180 and 360. 0 on the y-axis. Cos, on the other hand, well, it's 0 on the 90 and 270. That's the, and then to check if it's inverted, yeah. Um, right. So that's the only way to identify the two. Okay. Do you think me really explaining it will help you? Okay. Does anyone who attended the class here understand graphs?
Yeah, nah.
Kinda.
Yeah, you lying, Steppy, so I eat you.
Nah, bro, kinda, bro. I'm being so honest.
Now I know how to identify them and stuff, but then
Yeah.
once it gets into the meat, it's like it's chai.
Which part? Because right now what I did was um they gave me the graph and I must get the formula. If they give you the formula, it's easy because then you're plotting the graph. Then you're just gonna say 90, 0, 90, 180, 270, 360.
Can't you just put that in your calculator?
Yeah,
Find it.
using that method.
So then the plotting is easier.
Much easier.
Wait, for your plotting, your start would be 1, right?
You start at 0, the origin.
Oh, I started 0.
You
Okay.
end at 360, your step is 90.
Bet. Thanks.
Okay, in that case then